Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before we proceed, I'd like to request our members to kindly subscribe to our channel and also check our description boxes for various links of other similar videos which I'm going to put there. Now in this case, today we're going to look at the concept of the partition function. And of course, as I had mentioned from our last discussion, there were various thermodynamic variables which we had considered in terms of a summary. And of course, there are various range of videos which we have done on the individual aspect of those specific thermodynamic quantities or variables which I've mentioned. Now, to list a few, I said that we have what we refer to as Helmholtz free energy, which is given in terms of the difference between energy given as such and the product of absolute temperature and entropy. And now, in this case, I'm just going to mention them in that short summary. And then we said that we can have another variable referred to as Gibbs free energy given as a ratio between enthalpy and the product of temperature and entropy given as such. And of course, we can list others. This one implying internal energy. And of course, we're going to rely heavily on this one in this specific concept of a partition function being represented as UA in this specific case. And then I have talked about the concept of enthalpy. And this is also a state function represented as a product of E and the, of course, or rather the sum of E and the product of temperature and volume. And of course, we are going to have different ways in which we're going to represent this one in trying to vary different aspects of the various variables of pressure, temperature, and volume in that specific case. And that's going to be represented in terms of a delta A, delta G, delta E, delta H in that particular order. Now, the aspect of T basically implies absolute temperature. And this is going to be the temperature in the Kelvin scale, as we have been mentioning. Now, lastly, we're going to have what we refer to as chaos or the disorder of a system, which is given in terms of entropy. And these are some of the specifically the thermodynamic variables which we have discussed in one way or another in some of our videos. Now, the concept of the partition function is going to be very, of course, important in a sense that it's going to be all of the thermally accessible energy levels can at a particular temperature can be represented in terms of a partition function in that case. Therefore, this is going to represent, of course, the number of thermally accessible energy levels of a system at a specific temperature. And as I said, of course, the relevance of this is that this specific partition function can be used to represent the thermodynamic quantities which are given in this specific case or listed on the board, among others, in terms of this specific function. Therefore, in our subsequent videos, I'm going to use various ways of representing this partition or the variables in terms of a partition function. And of course, we're going to start by basically defining this, of course, a partition function in terms of a algebraic representation. So therefore, the partition function can be given in terms of, or the total partition function can be given in terms of Q as I've said. And this is going to be represented as the summation of all the accessible, or rather the thermally accessible energy levels at a given temperature, given in terms of this one. And of course, I'm just going to put this one as all levels. And we're going to be specific as we go ahead on some of the specific, perhaps representation which I've given on the board. And this is going to be the negative exponent of KBT given as such. And of course, in this case, we're going to see that this specific aspect of the exponent is going to be represented in different variables. And we're going to rely heavily in trying to represent this specific internal energy in various aspects of the variables which I've mentioned on the board. Now, I've given a specific representation, and this case is still this specific aspect of the partition function can be represented using a particular notation, whereby we're going to consider, of course, a notation that is going to take account of the inverse of the product of K, B, and T. And in this case, I'll be given K, B, T. I'm going to elaborate on what basically that one represents in this specific function, whereby the concept of T, as I said, this represents the absolute temperature in Kelvin scale, and then we're going to have the K subscript B representing the Boltzmann's constant, And of course, that's a constant value which we are going to come across as we go by. So therefore, we're going to have an aspect of notation which is going to be given in terms of this specific partition function, whereby we're going to use this b to represent, or this particular case for beta to represent this aspect of 1 over k bt. So this is the specific symbol with b with an elongated stroke at this specific point, because I'm going to mention what it basically implies. But we're going to have this one represent the inverse of the product of kbt given as such. Therefore, we can have our partition function represented in that specific notation, whereby we're going to have E given as the summation over all the thermally accessible energy levels and the exponent of a negative. So we're going to have this specific symbol substituting this specific value of the inverse, or the 1 over kbt, and therefore this is going to be given in terms of P, the energy of that particular system given as such. And this is going to represent our general aspect of the partition function. Now, as we go ahead, we're going to use various representations for the variables which I've mentioned, representing this specific aspect of those variables in terms of a partition function, which are given in this specific point. So kindly be taking note of this particular representation or notations that we're going to use in our various videos, and I'd like to invite us to our next discussion, whereby we're going to look at various variables being represented in terms of this, of course, thermally accessible energy levels at a given temperature. Kindly check our description boxes for various links of other similar videos, especially on thermochemistry and physics, which are going to play a complementary role in assisting us understand. So that is it for now, guys. Bye, God bless. We'll catch us in our next video.